Alright, so that last video was 17 minutes. Wow, it sure went fast for me. Hopefully this one will be pretty short. I don't have much more to say here. Describe the bonding and hybridization. I didn't do that for number 3. Refer to the last video because I ran out of time. And identify nucleophiles and electrophiles in organic reactions, and then draw curved arrows. Sounds like a lot. But this is the story of the rest of our lives here in organic chemistry. So I'm going to use a few examples from alkenes, but got to understand that this is what we're going to be doing the rest of our lives. So describe bonding and hybridization in alkenes. Let me not say a whole lot about that. It turns out that this is an sp2 hybridized carbon. This is an sp2 hybridized carbon. This is sp3. All right. One way to think of that is how many electron groups are around this one. It's got a hydrogen, and a carbon, right, over here. So there's only 3 electron groups. And so if you look at the superscripts here, the sum of those is 3. This one has 4 electron groups, right? It's got a carbon and 3 hydrogens. So the sum of these superscripts is 4. All right. Carbon dioxide, I think, is a little tricky. How many electron groups around the carbon in carbon dioxide? Only 2. So this is sp hybridized. What about nitrogen and ammonia? Right, if those are hydrogens, that's ammonia. What is that? 1, 2, 3, 4 electron groups, so it's sp3 hybridized. Okay. So what about that? What's the hybridization of this oxygen right here? There's 1, 2, 3 groups. That's sp2 hybridized. All right. And then the final thing we want to say about this structure and bonding is that this thing is planar, and that's a big deal. Planar. Okay, and we'll come back to that many, many times. All right, next thing we want to do is we want to talk about electrophiles and nucleophiles. Wow, what's that? How do you spell nucleophile? N-U-C. Nucleophile is a nucleus lover, or a positive charge lover. Okay? Phile means lover. And an electrophile is, you guessed it, an electron lover. Okay? Or a minus thing lover. Okay? So, all right. Just in case you didn't get that. Okay, so that's what a nucleophile is. Well, what's going to be something that loves a nucleus? Well, I mean, shoot. Let this be some sort of some atom, okay, with a lone pair of electrons on it. Boom! Look at that. There's 2 electrons right there, and they are nucleus lovers. Okay. Well, if they're nucleus lovers, then this guy, you can bet, is an electrophile. Okay, and that's correct. Now we're going to be doing these curved arrows just like we did in our first mechanism. We've only done one mechanism. Does anybody remember what that mechanism is? What mechanism have we done already? And the answer is, I'm not going to tell you, but in that mechanism, we drew the action of electrons with a curved arrow. The overarching question in all of organic chemistry is, what are the electrons going to do? That's the overarching question. What are the electrons going to do? And if you answer that, everything else is easy. We're going to answer that by considering 2 things: structure and polarity. So we're going to spend some time talking about structure. We're going to spend some time talking about polarity. But that's always for the purpose of answering the overarching question: what are the electrons going to do? Okay? So, this is what the electrons are going to do. Boom. That's an arrow. Curved arrow notation. We're going to use that to describe what the electrons are doing. And so obviously a wrong answer for this would be, if we were going to say some kind of reaction that we've got going on there, that's a wrong answer, because that's telling what the protons are doing. Okay? We're always concerned about what the electrons are doing. It's curved arrow notation. So let's look at alkenes and say structure and polarity. If we're considering these two things about alkenes, let's look at that. Actually, what I want to do is I want to bring this out of the plane and bring it perpendicular to the paper. So in order to do that, I'm going to bring that methyl group coming toward me, or whatever that is. And then now we can see we've got a top and a bottom, right? There's the top, and the other side's the bottom. Okay? Top and the bottom. Now, tell me, where are the electrons? Well, most of the electrons are actually in between. So it turns out, and sometimes we have real obvious electrophiles and nucleophiles, but in alkenes we really don't. You're going to have to memorize that the middle of the alkene is partial negative. And the carbons are partially positive. Okay? So, if we have an alkene and we're going to react, say, an acid with it, which acids generally look like that, what do you expect? What do you expect? That's a good question. Where's the electrophile and where's the nucleophile? And that's really the question that I'm asking for you here. So, question number 1, ID electrophile. Question number 2, ID nucleophile. Question number 3, draw curved arrow. And that's it. That's what we're going to be doing always in every mechanism. Every every mechanism, we're going to be doing these things. Identify the electrophile, identify the nucleophile, and draw the curved arrow. This is a big deal. It shows up as, two lesson objectives in lesson 16. We've already done this in our first mechanism, the name of which I'm not going to tell you. We've already done this, and we're going to keep doing it. So, for a quiz tonight, or for your general edification, or for, I don't know, good conversation at the family reunion, please be ready to answer what is going to happen here. Okay? Good luck.